There we are. Nice to meet all of you. My name's Maurice. I'm one of the founders at Atla. We're an AI safety company based here in London. And as advertised, we train AI evaluators or LLM judges. How many of you are familiar with the term LLM as a judge? Okay, not too bad. Cool. How many of you have run an evaluation with an LLM as a judge? Less. And have any of you fine-tuned an LLM as a judge? All right, those are the pros. Cool. Nice. For those of you that have no idea what I'm talking about, an LLM as a judge is a popular way to grade your AI-generated output using another LLM. Essentially, you prompt one LLM to be kind of the judge or the teacher of another AI, and you tell it to grade its outputs according to some criteria that you care about. We train these models, but today I want to show you something that's kind of in beta that we've been hacking together that isn't live yet. We call it our alignment platform. And to motivate this a little bit for you, I think something we hear a lot is, I can't really trust benchmarks because they don't really mean anything about my application. Also, I need a custom evaluator, or there's something that I really care about in my GenAI application that I have to test individually and sort of purposefully. And so we built this thing that helps you align one of those AI evaluators to your particular use case. And I'll try to do this with an example live. It's in beta, and I'm gonna run some live code. So bear with me as this probably breaks, but let's hope. Cool. So first things first, I will just try and generate an eval prompt. So I'm prompting the student now. Yeah, let me try to make this bigger for you all. Also probably not very responsive to screen size yet, but yeah, it's not bad. Cool, so yeah, I'll start by kind of selecting a template here. I'll just pick faithfulness. I'm gonna make this a binary evaluation. I'm gonna show you in a minute why I do this. And then I'm generating this eval prompt. So this is the prompt that the teacher or the judge is seeing on how it's supposed to grade our application. And I will call this custom hallucination. And I'll try to now align this metric, right? Kind of make it count for my application. And here's then, I'm going to zoom out a little just for a second to find my test cases. A collection of test cases that are relevant to my use case. This, in this case, is just a publicly available hallucination data set, which includes some instances where I essentially have some context. This could be, right, a RAG application where I've pulled some true facts, and then I have user input, which in my case is a conversation between a human and an AI assistant about movies, and the response generated by the AI application. And then there's an expected score where we're going to label this together in a second. So this all comes from this data set. It's called Halu Eval, a famous hallucination data set on Hugging Face. And I happen to know the labels here. So you can see I just copied out the first 5 samples into our alignment platform. And the first one's hallucination. Then 3 of them are okay, and the 5th is, again, a hallucination. So I'm just going to set the expected scores accordingly. This is a little bit confusing because we treat a hallucination here with our prompt as a 0. And if they're fine, they treat it as a 1. And now what I'm going to do is I'm going to run our model over this with the prompt that we had earlier selected, the template. And when I run this eval, you'll get scores, and you'll see that they're bad, right? Essentially, this very much disagrees with kind of the human scores that we would expect. And the reason is that essentially the prompt template that I used is not very well suited for this task. There's a subtle difference that it's doing here. It's evaluating whether it's well grounded in the facts versus what I'm trying to actually find for my application is straight up contradictions, which are sort of different. And so what I'll do to improve this is I'll just add few shot examples to my model prompt by doing this way. And so essentially what I'm doing here is I'm like way overfitting on these 5 samples by just few shotting them. And then I run this again. You can see now it gets a few more of them right. It still gets 1 wrong, but this is probably fine enough. And now I can deploy this, and this is now my custom evaluation metric, this custom hallucination parameter here that we've defined. And I've set this up here now with kind of the larger data set that I've showed you on Halu Eval, which has these 10,000 instances. And to make this runnable, I just did this before I came on stage. I ran this once with the template, and you can see that the accuracy is terrible, right? It does even worse than average guessing. It's just zeros and ones. You can see that it has this massive bias towards saying these are hallucinations because it thinks it's not well-grounded. And now what I'm going to do, I'm going to change this parameter, which here was the faithfulness template, to this custom hallucination that I just defined. And essentially, I'm going to run this again. And this might take a few seconds. And while this runs, I'm going to tell you a little bit about how we trained the model. And then we'll come back to it and see if it did any better now that it had a few shot examples to learn from. Cool. Yeah, as Matt alluded to it, we trained a SOTA AI Evaluator, or LLM-as-a-Judge. This is the stats from our small model, the Mini, which we open sourced 2 weeks ago. We have about 10,000 downloads so far on Hugging Face. Please go download it, use it if you're using an LLM-as-a-Judge. It's really good, it's fast, it's small. And we have a bigger one coming next week, which is going live very soon. So yeah, excited if more of you folks want to use those for your evals. I'll talk a little bit about the kind of secret sauce. As everybody always says in training your models, the data is kind of the secret. And I think in our example in particular, it's the curation strategy that really made the difference. So to teach an LLM judge its task, we show it a lot of human preference data. And there's a lot of human preference data kind of available on the internet. That are data sets on Hugging Face. You can intuitively think of things like Reddit upvotes or kind of human preferences as well, right? The thing that's not usually available is critiques. So why is a good answer good? Why is a bad answer bad? And so this is the piece that we synthetically generate. And the whole pipeline has sort of different steps. You can see here in yellow is kind of filtering. So the first thing we do if we find a data point online that we like, or a data set online that we like, it usually has this judgment, right? It has like a label in it. And then we filter basically first off to just make sure that actually the labels are any good. So this is the reward filtering we do. And then we synthetically augment them with these critiques. So we essentially rationalize the scores for the model so that it learns what a good score and a bad score looks like. Then we do a bit of consistency filtering. So we want to make sure that one, the score aligns with the critique, but we also want to make sure that like the critique actually picked up on the thing that's what's being evaluated, right? If someone's evaluating for conciseness, I don't want the critique to say, oh, this is like a very creative answer. Like that just has nothing to do with it. So we do a bunch of filtering, and then ultimately we get this training data mix, which is then what we train the model on ultimately. This is the reward model we use. We picked one off the shelf. It's publicly available. And essentially what it does is it labels, it goes over the data points that we find, the labels, and it gives us a score. We then use a threshold and say if it's underneath this particular score, we don't think it's a very good example to train our models on. The key here is kind of to find the interesting data points. And the interesting data points tend to be at the decision boundaries. So we want to find examples that are like maybe very close to a hallucination, but they just aren't. Or maybe they just are, and then there's a critique to that. And so this helps us kind of get to the high quality, difficult cases to evaluate, high quality samples for us to train on. Yeah, like I said, we then augment them with these critiques, right? This is a sample. You can probably barely see this. I'll try to make it bigger, where we have kind of a yes/no answer, and then we generate this reasoning so that you can follow the chain of thought of your evaluator, that it does essentially the right thing. Yeah, then we do consistency filtering. This is just to show you these data sets are not all that consistent when you find them. This filters out about at least a third of all the data sets, right? This is one data set each. And then like the yellow ones are consistent, the mixed ones are not so great, and no is like clearly a contradiction between for example, the label and the critique. The critique says this answer isn't a hallucination. The label says, in fact, this is one. Not so great. Probably don't want to train on that. And then this is the final data mix. I'll make this a little bigger for you as well. It's a very wide variety of topics and data points that goes in there. It's about 500,000 data points or so that we ultimately used for the training run. And that's it. Let's go back and see how we did on this new eval now that I've run it. Oh, yeah, great. We jumped to 82. This is a lot more green than it used to be, so we're doing much better than random guessing with a few samples. So it seems to have picked up on the right things. Also, the score distribution is a lot healthier yet. Not perfect, right? I would probably want to go back and do some more prompt engineering of my evaluator, but for a quick fix for a live demo, not too bad. Yeah, that's me, that's us. Please find our model on Hugging Face. Sign up for our bigger model that's coming out next week. And if you have any questions, let me know.